All right, so this is going to be the test review for tomorrow's test. We'll go through the solutions. Recalibrate the screen real quick. Okay, so looking at the test review out of the book that we started to work on in class today, we're determining on number 3, we're determining whether or not we have a quadratic function or not. So again, there's a primary difference is that if I ended up saying to you, I gave you two functions, y equals x and y equals x squared. Well, which one would be the quadratic function? Well, we would pick the x squared as the quadratic, and the reason why is because we have a square as the highest exponent. So we can kind of look through these problems right here and see that number 3 is a quadratic because it has a square as the highest exponent. Number 4 is not because it has a highest exponent of 1, which makes it linear. Number 5 has a square in it, so this is a quadratic. And number 6 has a cube, so it is not a quadratic. Okay? So for number 7, we are going to use a table of values to graph each quadratic function. So we have an x and a y. We have -2, -1, 0, 1, and 2. And we want to find out, okay, if I plot those points, where are they going to be? So we're going to plug in -2 for x. And we get 6 times 4, which equals 24. Okay? So now we can go ahead and look at -1. So we have 6 -1 squared, which is 6 times 1 equals 6. Okay? So we can erase this one. And so when we plug in 0 for x, we get 0. And then a parabola gives us the ability to be able to reflect these points. So if -1 is 6, 1 will also be 6. -2 is 24, well 2 will also be 24. So now I can go ahead and plot these. Well, this number 24 is kind of way up here on the y-axis. So I'm going to probably want to go ahead and adjust the scale of my y-axis to go up by 2's. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay? This is just, again, a sketch of the graph. We're estimating where these points are going to be. Okay? Actually, I did that wrong. So we have 6. So we have 14, 18, 22, and 24. Okay, so now we're going to plot our points. So again, I can leave my x-axis by 1s. And so we have -2, and we have 24. We have a point right here. Let's get this out of the way so our graph's a little bit clearer. So we have -2, positive 24. We have -1, positive 6. We have 0, 0. And then again, I'm going back 1 and 6, and 2 and 24. And now I have plotted that parabola. Okay? So we would do the same thing with this function right here. Only note that this one is going to open down because it has a negative sign for the leading coefficient. Okay? So moving on, that kind of addresses the next questions, whether or not they open up or down. So here we have the leading coefficient, that's the coefficient in front of the highest exponent. If that is positive, then it will open up. Okay? If that leading coefficient, in this case, is -1, if that's negative, then it will open down. To find the zeros of a function, we're simply just finding where this graph crosses the x-axis. Now notice that this goes up by scales of, it's a scale of 2, -2, -4, -6. And then we have 2, 4, and we go 6 there as well. So this is -2, I'm sorry, not -2, +2. And here we have -5. So those are my two zeros for that function. Here we have -1 and 2. Those are my zeros for the function. So graphing these quadratics. So if we just go ahead and look at number 15 first. So we have y equals x² plus 6x plus 6. So the first thing I want to do is get my axis of symmetry. Okay? Which is x equals -b over 2a. So in this case, we have -6 over 2 times 1, which gives me -3. So we have a graph here, and we have an axis of symmetry at x equals -3. Okay? So now we're going to find the vertex. Okay? Well, when I plug -3 into the function, what do we get back for y? So we have -3 squared plus 6 times -3 plus 6. So we have 9 minus 18 plus 6 will give me -3. So this is my vertex, -3. So we have -3, -3. So this is my vertex. Okay? Now, we are going to find my y-intercept. Okay? My y-intercept, pretty easy to locate. Last number here is going to be 6. So my y-intercept is going to be all the way up here at 6. So now we want to find one more point. One more point that will give me what I'm looking for. Somewhere, and I'm going to look, I really want to try and find something in between my axis of symmetry and my y-intercept. That's what I'm looking for right there. Okay, so I'm going to pick an easy one, which is going to be, let's use purple, -1. So we have -1 squared plus 6 times -1 plus 6. So we're going to have 1 minus 6 plus 6, which gives me 1. So when x equals -1, y equals 1. That is my other point that I'm looking for. Now I can reflect those points. So if this one is 2 away, need a little bit of room here. This can be 2 away, so then this one will be 2 away. If this is 3 away, then this one will be 3 away. And then here we have a sketch of our parabola. Okay? So we should be able to determine from that how we would do number 16. I went ahead and put number 20 in for the primary reason that looking at this function, I need to go ahead and set it equal to y. I need to put it in standard form. So in order to do that, I need to simplify this. So I'm going to go ahead and subtract 2 first. So I have -4x squared plus y equals 8x minus 2. Now I'm going to add 4x squared to both sides, squared. And this gives me y equals 4x squared plus 8x minus 2. Now we can utilize the same methods, the axis of symmetry, the vertex, the y-intercept, other point, and reflect those points to graph that. Okay, last we are talking about translations. Okay, so if we were just looking at these functions for a second, okay, let's go ahead and open up the apps for the graphs here. So looking at these two functions, we have 2x squared and 4x squared. So again, when we apply transformations to these, we are working first with the parent function. So we have y equals x squared. This is our parent function. Okay? So we said, okay, well, if that leading coefficient is going to be greater than 1, if this number is greater than 1, then we are stretching it. We're pulling this parabola up so that it gets a little bit more narrow. Okay? So then if we went ahead and increased that number even further, then we're making it even steeper here. So that's basically what we're looking at here. We're saying, okay, which one from narrowest to widest? Okay, so the larger this number is, the more narrow that graph becomes because we're stretching it up high. So then from narrowest to widest, we have g of x is the narrowest to the widest, which is f of x. These two next, negative 6x squared and 6x squared. So if we just go back here for a second, leaving the parent function in place so we can kind of see what that looks like. We have y equals 6x squared, okay? So that's that parabola. And then we have y equals negative 6x squared, okay? Well, they are the same width. Okay, they're the same width. However, if we were just to look at this for a second, okay, so if these were the same, the only difference in the two functions is that we have now reflected it across the x-axis. The width, if we were just look here at negative 5 and 5, they're the same width. So if we go back to our graph, these have the same width. Okay? So 24, from narrowest to widest, we're going to have h of x, g of x, I'm sorry, not g of x. We're going to have h of x, because that's 3. Then we're going to have f of x, because it's 1. And then we're going to have g of x, because it's 1/3. Okay? So we're comparing this function, these functions right here, to the parent function, x squared. So again, just looking at graphs for a second. Okay, if I have a parent function y equals x squared that I'm comparing this to, and I have y equals x squared plus 5, then again, the only thing we've done is we have translated it up. Up 5 units. Okay? We have two transformations here, this 3 right here and this negative 1 right here. So again, if we just look at the graph and come back to this for a second. So from the parent function, that 3 says, okay, well, we have applied a vertical stretch by a factor of 3, and then we moved it down 1. So we have two transformations, vertical stretch by factor of 3 and translated down 1 unit. Okay? Same thing here. You can use the prior example to see what it is of our transformations here.